Hi and welcome to this A-level maths lesson looking at differentiation. So this is going to look at the year 1 differentiation material. I will record in a couple of weeks a separate video going through the year 2 differentiation material. So we're going to start by reminding ourselves what differentiation is and the purpose of it, and then we're going to have a look at a typical exam question from the 2018 pure maths paper. Using differentiation. So differentiation is when we reduce the power on our function. So if I begin with y is equal to x to the n, then dy by dx is equal to n x to the n minus 1. And I prefer the dy by dx notation. It's absolutely fine if you prefer the function notation of x to the n and f primed x is n x to the n minus 1. Either is fine. I'm just going to, for the rest of this video, use dy by dx rather than the function notation. But if you prefer the function notation, that's absolutely fine. So what is the point of differentiation? Well, differentiation gives us the gradient of a curve, and we can use that to find the stationary points. So a stationary point is a point where the gradient of the curve is equal to 0. So if I have that y is equal to x cubed plus 2x squared minus 1, then I can say that dy by dx, remember I just differentiate each term as it comes, becomes 3x squared plus 4x, and the 1 disappears. So if I wanted to find the turning points of my original curve, I would make dy by dx equal to 0. I would then solve that equation to say x 3x plus 4 is equal to 0, and therefore x is equal to 0, or x is equal to minus 4/3. I could then substitute those x values back into the y equation that I started with, y equals x cubed plus 2x squared minus 1, to find the y coordinates of the turning points, of the stationary points. If I want to know if those points are a maximum or a minimum, then I differentiate again, and we call this the second derivative. So this would give us our d2y by dx squared. I would differentiate again, substitute in my x values that I found, and find out if this was greater than, less than, or equal to 0. If my second derivative is greater than 0, then I have a minimum. If my second derivative is less than 0, I have a maximum. And if it's equal to 0, I either have a minimum or a maximum or a point of inflection. Now, people always forget point of inflection. A point of inflection is when you might have a cubic, and it's that point there where the gradient is 0, it's a horizontal line, and then it carries on in the same direction, unlike a maximum or a minimum, which are very evidently maximum or minima. Now, we can be asked modelling questions where we're asked about the cost of something or the volume of something, and then we're asked to find the minimum of that value. And again, we just differentiate in exactly the same way as if it was a graph. We differentiate and we substitute in our values. We make it equal to 0, then we substitute in our values to find the minimum volume, cost, whatever the situation is. And there is a worksheet that accompanies this lesson that has a couple of those types of questions on it for you to have a practice. Now we're going to quickly run through a question together now, so you can see the kind of question that you might be asked around differentiation. So a curve C has equation y equals x squared minus 2x minus 24 root x. Now, to solve this, the first thing I'm going to do, as soon as I see that I'm going to have to differentiate that, I am going to rewrite that as y equals x squared minus 2x minus 24x to the power of a half. Why am I doing that? Well, it means that that root x is instantly easier to work with when we're differentiating. Now, dy by dx, find dy by dx, nice and straightforward, hopefully. Pause the video and have a go yourself. That would give us 2x minus 2 minus 24 times a half is 12x to the minus a half. Find d2y by dx squared, d2y by dx squared, finding it very hard to write small today. That would be equal to 2, the minus 2 disappears, and then I've got minus a half times minus 12 gives me plus 6x to the minus 3 over 2. Verify that C has a stationary point when x equals 4. Now, this is slightly easier because instead of making dy by dx equal to 0 and solving to find that x is equal to 4 at the stationary point, we can just substitute x equals 4 into our dy by dx. And if it's equal to 0, then we know that that is a stationary point. So I'm going to substitute in 2 times 4 is 8 minus 2 minus 12 over root x, or root 4, which is 2. So 8 minus 2 minus 6 gives me 0. So we do have a stationary point at x equals 4. Finally, determine the nature of this stationary point, giving a reason for your answer. So this is where we substitute x equals 4 into our d2y by dx squared. We've got 2 plus 6 over the square root of 4 cubed. Well, 4 cubed is 64. The square root of that is 8. So I've got 2 plus 6 over 8, or 2 plus 3/4, which is 2.75. So that is greater than 0, and therefore I have a minimum. Now, quick note, in a mark scheme, if you had not put this greater than 0, you would not get the mark for just stating that it is a minimum. You have to show that you have understood that because the second derivative is bigger than 0, it's positive, that means that our stationary point is a minimum. So just make sure you're really clear and explicit on how you've managed to deduce that that is a minimum. And there we have it. What a lovely 7 marks on our 2018 pure maths paper. And that is year 1 differentiation in a nutshell. If you have any questions or comments, pop them in the box. Go and have a go at the practice questions. They are entirely free with solutions. The link is in the bio, the description box. But otherwise, thank you guys for watching, and I will see you next time.